You know, we've all had that heart-stopping moment, right? That clumsy trip, that slip, that little fall that leaves you with a nice big bruise. It's a primal fear. It's just hardwired into us. But have you ever actually looked down from a really great height and wondered, scientifically speaking, what are the absolute limits of human survival? So today, let's actually dig into the science behind the fall.
This is the big question we're tackling. I mean, is there some specific height where survival just becomes totally impossible? Or is the answer a little more complicated than that? Well, to even begin to figure this out, we first need to get a handle on the one physical law that rules every single fall, no matter what.
Because when you're falling, yeah, the height matters, but you know what's even more critical? It's the speed of your impact. And believe it or not, there's actually a cap on how fast your body can go, no matter how high you fall from. It all comes down to this one crucial concept: terminal velocity.
So what is terminal velocity anyway? Well, put simply, as you fall, you speed up. That makes sense. But as you go faster and faster, the air resistance pushing back up against you gets stronger and stronger. Eventually, you hit this point where the push from the air perfectly balances the pull of gravity. And right then, you stop accelerating. You just keep falling at a constant maximum speed.
For a human being falling through the air, that ultimate speed limit is right around 200 kilometers per hour. That's about 125 miles per hour. Now, this can change a little bit depending on your body position. You know, a skydiver in a spread eagle pose falls slower than one diving head first. But this is a really solid average. That is the fastest your body can fall, period. But what's really surprising is how quickly you actually get to that speed.
You hit terminal velocity after falling just 60 meters. That's only about the height of a 20-story building. And here is the mind-blowing takeaway from that. Beyond that height, the physics of your impact doesn't change. Whether you fall from 60 meters or from a cruising airplane at 10,000 meters, your impact speed is going to be exactly the same. Okay, so with that in mind, let's break this down. We're going to climb what I'm calling the ladder of peril, level by level, just to see how the risks escalate with every single meter. And we'll start with falls that are, well, probably a little too familiar for some of us. So at just half a meter, about knee height, you trip. You might get a scrape, maybe your ego's a little bruised, but that's it. Your body barely builds up any impact energy. But jump up to just 2 meters. Imagine falling off a tall refrigerator, and the whole game changes. The impact force is so much higher, which is why you see parkour athletes spend years learning how to roll, to spread out and absorb that energy when they land. All right, let's keep climbing. At 5 meters, we cross a really critical line. We're talking about the height of a 2-story house, and it's right here that trauma studies mark the transition from injuries being just moderate to being potentially fatal. And you can really see that jump in risk here. At 5 meters, we're way beyond just a few broken bones. Now we're talking about vertebral fractures, serious brain injuries if you hit your head, and major internal organ damage. Yeah, survival is possible, but walking away from that unscathed is highly, highly unlikely. And as we go higher, the numbers just get darker. At 10 meters, you hit the ground at 50 kilometers per hour. That's like crashing a bicycle head-on into a wall. At 15 meters, the impact speed is up to 65 kilometers per hour, and mortality rates are just extremely high. If you land on your feet, the force can literally shatter your legs and drive your pelvis up into your vital organs. And then, at 25 meters, that's about 8 stories, your impact speed is nearly 80 kilometers per hour. In the world of trauma medicine, this is considered a lethal height. That sudden stop causes catastrophic damage. The body simply isn't built for that kind of deceleration. But there are always exceptions. And yet, despite these terrifying statistics, people have survived falls from incredible heights. So how is that possible? If your speed is constant after just 60 meters, what's the variable? What's the one thing that can change the outcome from certain death to an absolute miracle?
Well, here's the crucial secret. It's all about the stop. To survive, you have to increase the amount of time it takes for your body to go from 200 kilometers per hour all the way down to 0. Anything that can cushion the impact and absorb that energy gradually, that's what gives you a fighting chance. Think of deep, fresh snow, a dense canopy of trees, or soft mud. They all act like a giant natural airbag. And that brings us to the most extreme case on record, a fall from 10,000 meters. Let that sink in for a second. That's over 33,000 feet, the cruising altitude of a commercial jet. It sounds utterly impossible to survive, but it happened.
Back in 1972, a flight attendant named Vesna Vulovic became the sole survivor when her plane exploded in midair. She fell from over 10 kilometers and lived. The question is,
How on earth did a 1 in a billion series of events line up to save her life?
Well, there were three key factors. First, she was trapped inside a big piece of the plane's fuselage, which acted like a protective capsule around her. Second, and this is so critical, that piece of wreckage didn't just slam into the ground, it hit a steep, heavily snow-covered mountainside. This allowed it to slide for a long distance, bleeding off that deadly speed gradually. And third, she was unconscious for the entire fall, which meant her body was completely limp, preventing the kind of tension-related injuries that often happen.
All right, so after looking at the hard physics on one side and the absolute miracle exceptions on the other, where do we land? What's the final verdict on the limits of human survival?
If we take out the billion-to-1 miracles like Vesna-Volovich, the realistic limit seems to be somewhere in the range of 20 to 30 meters. Now you would need a perfect landing position on a surface that gives way just right and, let's be honest, a whole lot of luck. But survival from that height is on the very, very edge of what's possible.
And that leaves us with this fascinating final thought. When you look at the science, a simple fall from just a few stories can be lethal, which makes us seem incredibly fragile. But then you hear these stories of survival against all possible odds, and they show an unbelievable resilience. So which is it? The answer, it seems, is both.